In this video, we'll do some simple circuit practice. So we'll have 3 examples in series and 3 examples with parallel circuits with some various different kinds of questions for each circuit. Remember to pause often to give yourself time to work, because learning happens best when you're doing it yourself. Just like if you were practicing a sport, the best way to practice the sport is to do it yourself. If you just watch somebody else do it the entire time, you're not going to get as good as if you did it yourself. Making mistakes is important, and trying your best is important. So some things to remember before we get to the examples is what series looks like and what parallel looks like, and all the different things related to them. So in series, just like binge watching a TV series, the resistors or devices come one right after the other with no branches. And in parallel, you have branches or choices that can be made. So if the electricity is coming in one spot, at some point you will have a junction where you have to make a choice of which way to go. Whether something stays the same or is different will depend on whether we're in series or parallel. In series, the current stays the same, and in parallel, the voltage stays the same for each branch. In series, the voltage, we can check our individual calculations by adding them together and seeing if we have the total voltage. In parallel, it's the current we can add together to see if we get the total voltage. These are not as useful for calculations for current and voltage. Most of the time we will use those properties, but we won't use those properties to calculate. Most of the time we will be using Ohm's law for calculations. The equivalent resistance, how we calculate the equivalent resistance changes depending on whether we're in series or in parallel. In series, we just add up the resistances of each resistor. In parallel, we have to add the inverses, and then as our final step, we have to take the inverse again. Because just this answer, if we add all of the resistances as fractions, we don't get the equivalent resistance. We get 1 divided by the equivalent resistance. But 1 divided by our equivalent resistance is not the final answer. And then the chart in blue has a summary of symbols. So symbols are what we see in the equations, and the equations you can see in the chart. So I is for current, V is for voltage, and R is for resistance. Also keep in mind that voltage has a couple different words that are associated with it. Potential difference is also the same as voltage, and electric potential are also the same as voltage. The units are what we'll get for our final answer. So for the unit for current is amps or amperes, which has a symbol of capital A. The unit for voltage is volts, which is also a capital V. The unit for resistance is ohms, which is a Greek letter omega. But if you are typing your answer, you can just write OHMS. You can write out the full unit. So example 1. Remember to pause the video so that you have time to do the calculations. So first question, what kind of circuit is this? Is this a series circuit or is this a parallel circuit? What is the equivalent resistance of this circuit? And what is the potential difference across resistor 5? Pause the video, try it yourself, and unpause the video if you get stuck or if you want to check your answer for one of the questions. This circuit is a series circuit. And we can tell by starting at the battery. So the battery is kind of like our start and finish line for the circuit. If we're thinking of the circuit as an obstacle course for electrons, our starting point and ending point is the battery. And we can tell this is a series because if we start at the battery, we have to go through every single resistor. We don't have any choice in which way we go. If we take our pen and trace the entire way through, we don't get any choices before we get back to the battery. What is the equivalent resistance of the circuit? Because we're in series, the equivalent resistance is found by simply adding the resistances together. So 2 plus 4 plus 1 plus 1 plus 5 plus 3. And our equivalent resistance is 16 ohms. What is the potential difference across resistor 5? So resistor 5 is over here, and it's asking us to measure across resistor 5. And remember, potential difference is another way for saying voltage. So it's asking us to measure the voltage drop across resistor 5. And this is how you would, I've drawn in green how you would attach a voltmeter or voltometer across a resistor. So like I said, for voltage and current, a lot of times we use those properties to identify some things about the circuit, but then we're going to use Ohm's law to calculate the voltage and the current. Since we're finding the voltage or the potential difference, we need to use voltage equals current times resistance. What resistance are we going to use in this situation? Are we going to use 16 or are we going to use one of the other resistances? In this case, because the question asks us for resistor 5, the potential difference across resistor 5, all of these pieces of information in our equation need to be about resistor 5. So this current needs to be the current that's going through resistor 5, and this resistance needs to be the resistance of resistor 5. What current is flowing through resistor 5? We do have an ammeter in this picture. So this ammeter is telling us that in this part of the circuit, there is 0.75 amps of current being measured in that part of the circuit. Is there 0.75, if we put an ammeter next to resistor 5, would it tell us the same number? Would it tell us that there's the same amount of current at that part of the circuit? Or would there be a different current at that part of the circuit? Because of this, because we have a series circuit, current stays the same in series. And what that means is no matter where we place the ammeter, we could place the ammeter at any point in this circuit, and every place in that circuit will measure 0.75 amps. So what is the current going through resistor 5? The current through resistor 5 is 0.75 amps. And remember that our obstacle course comparison. If this is an obstacle course and we had 7 runners start the race, then 7 runners need to finish the race. And if they can't take any choices, if they can't make any choices to avoid a resistor, then every resistor, every obstacle will have 7 runners go through it. And current is like our amount of runners. So if 0.75 amps of current starts off the circuit, if 0.75 amps of current starts out the circuit, then 0.75 amps will go through every resistor in the circuit, and 0.75 amps will be the current at the end of the circuit. The resistance of resistor 5 is 5 ohms. So 0.75 times 5 is 3.75 amps. .75 volts. So the voltage or potential difference across resistor 5 is 3.75 volts. For problem number 2, what kind of circuit is this? Rank the current through each resistor from greatest to least, and determine the potential difference provided by the battery. Pause the video and try to work through this yourself as far as you can, and then if you get stuck or you want to check your answer, start the video up again and then pause it when you need to. What kind of circuit is this? Some students will get confused by the voltmeter and the ammeter, but the important part of this circuit is what I'm highlighting in green. Voltmeters and ammeters are measuring devices. They don't change the circuit itself. Just like if you were measuring the velocity of something, just simply measuring the velocity doesn't change the velocity. You're just measuring it. So voltmeters and ammeters don't change the circuit. So this kind of circuit is a series circuit. Rank the current through each resistor from greatest to least. This one's a bit of a trick question because current through each resistor in series is all the same. So all the current through every one of these resistors is the same. Last question, determine the potential difference provided by the battery. For this one, again, we need to remember that potential difference is another word for voltage. And in this case, whenever we see battery or the entire circuit, that's a hint to tell us about the totals. So we're looking for the total voltage for the circuit. Again, because we're looking for voltage, we're going to use current times resistance. But this time, instead of looking for individual currents and individual resistances, we're looking for total voltage, which means we need to know the total current and the total resistance. Because the current is all the same, just like in the last one, it doesn't matter where this ammeter is placed. We will have 0.5 amps of current through every resistor, and that will also be our total current. For the resistance, we need the total resistance, which is also called the equivalent resistance. And in series, we need to add the resistances together. So 1 plus 2 plus 3 plus 4. So we have 10 ohms of resistance in this circuit. 0.5 times 10 is 5, and we just found the voltage or the potential difference, so we have 5 volts. So this voltmeter would read 5 volts. Example 3. What kind of circuit is this? Rank the currents in each section from greatest to least, and we'll call this ammeter number 1, ammeter number 2, ammeter number 3, and ammeter number 4. Ammeter number 1, ammeter number 2, ammeter number 3, and ammeter number 4. Determine the current through the 10 ohm resistor and determine the equivalent resistance of the circuit. All 4 of these questions are independent of each other, so you don't have to solve them in order. If you get stuck, you can move to the next one and then come back to it. And also keep in mind that if you get stuck, you can restart the video and watch a little bit to help you get unstuck. Pause the video to give yourself a little bit of time to work. In this case, this circuit is a parallel circuit. We can tell because if we start at the battery, at a certain point, we have to choose which direction we go. Anytime you have a choice, you've come across a parallel circuit. Rank the currents in each section from greatest to the least. If you're a little stuck with this one, let me give you a hint before we solve it and see if this hint helps you. So you need to ask yourself 2 questions. Where is the total current? because whatever the total current is, that should be the greatest current. And then think about what kind of path electrons take. So pause the video if you were a little stuck and give yourself a little bit of time to think. Don't just don't just let the video keep running because you want to rush to the answer. Give yourself some time to think. Where do you think the total current is? And what kind of paths do electrons take? So the total current in this case will be near the start of the obstacle course for the electrons. So in parallel circuits, everybody starts the race at the same place, but then the electrons get to choose what branch of the circuit or what branch of the obstacle course they go through. And then as they return to the battery, they all come back together. So the total current is going to be the place where either they all start or they all finish. So in this case, the battery is here, which means this is our start and finish line. So ammeter number 4 is going to show us our total current. For the next part, for figuring out the current from greatest to least in the other branches, we need to decide what kind of paths do electrons take. Electrons take the path of least resistance. So in this case, our path of least resistance is the 8 ohm resistor. So that means the next one will be ammeter number 1. The resistance after that, that's the next least resistance path is the one with 9 ohms. So ammeter number 2 is the next one after that. And then ammeter number 3 will have the least amount of current. Determine the current through the 10 ohm resistor. Current equals voltage divided by resistance, but because we're looking at just the 10 ohm resistor, we need to know the voltage across the 10 ohm resistor and the resistance of the 10 ohm resistor. The resistance of the 10 ohm resistor is easy. It has 10 ohms of resistance. But what's the voltage drop across the 10 ohm resistor? In this case, we need to remember what stays the same in parallel. In parallel circuits, the voltage stays the same. That means if we hooked up a voltmeter across every resistor in this circuit, that means if we hooked up a voltmeter across every one of these resistors, they would all show us a voltage drop of 30 volts, which is the same as our total voltage in the battery. So 30 divided by 10 is 3, and we just solved for the current, and the unit for current is amps. Determine the equivalent resistance of the circuit. In this case, we have a parallel circuit, so we need to add the resistances as fractions. So 1 over 8 plus 1 over 9 plus 1 over 10. This is a difficult problem to do in your head because in order to add fractions, they need to have a common denominator. So for this one, I strongly recommend pulling out a calculator. And the answer that your calculator should give you is 0.336 with some other numbers as well. But be careful, this is not our final answer. We need to take the inverse again. So what that means, why is that? That's because this is 1 divided by the equivalent resistance. So what we need to do is, in order to find just the equivalent resistance, is we need to take 1 divided by 0.336, and then our answer will be 2.08 ohms. Many graphing calculators have a button that makes this kind of calculation a lot easier. They'll have x to the negative 1, or they'll have a 1 over x button, and that helps make the calculations go quicker because you're not having to type 1 divided by 8, 1 divided by 9. You press 8 and then the button, 9 and then the button, 10 and then the button, and that will still, and then press enter and it'll still give you 0.036. But then you can do 0.336 to the negative 1, and it'll give you the answer of 2.08 still. Problem number 4. What kind of circuit is this? Rank the current in each section of the circuit from greatest to least. And let me add some ammeters here. So this will be ammeter number 1, ammeter number 2, ammeter number 3. And then determine the potential difference provided by the battery. The third question, determine the potential difference provided by the battery. That is a 2-step question. Remember to pause the video so that you give yourself time to work and think, because it's always best to try things out. So again, this is a parallel circuit. Rank the current in each section of the circuit from greatest to least. And again, our 2 questions for ourselves are, where is the total current? And what kind of path do electrons take? In this case, the battery is over here, so that's where our start and finish is, which means the total current can be measured on this wire or on this wire. So in this case, ammeter number 1 is showing us the total current. Now that we've figured out where the total current is, we need to know what path do the electrons take, and they take the path of least resistance. But in this case, both paths have the same amount of resistance, so the electrons are just going to split evenly. So in this case, the ammeter number 2 and ammeter number 3 will show us the same amount of current. Determine the potential difference provided by the battery. So remember, potential difference is another word for voltage. And the battery gives us a hint that we're looking for totals. So potential difference equals current divided times resistance. But in this case, we need total current and total resistance. We know the total current because it's given to us by this ammeter. We don't know the total resistance yet. We need to calculate the total resistance at this point. So the total resistance, or the equivalent resistance, is 1 over 3 plus 1 over 3. This one's kind of easy to do in your head, so it will be fine to do it in your head. And our answer, 1/3 plus 1/3 equals 2/3. But remember, 2/3 is not our final answer. We need to take the inverse because this is 1 divided by the equivalent resistance. The equivalent resistance equals 3 over 2 instead, but physics prefers decimals to fractions, so let's turn that into a decimal. So our equivalent resistance, or our total resistance, is 1.5 ohms. 1 times 1.5 is 1.5. And we just found the voltage, or the potential difference, so our unit is volts. Question number 5. If the ammeter were moved to the right of resistor 1, would that change the reading of the ammeter? So if this ammeter moved to over here, would that change the reading of the ammeter? What will the ammeter read if it is to the right of resistor 1? Pause the video to give yourself some time to think. Even though it didn't ask this question, it is important to ask yourself, what kind of circuit am I looking at? And for this circuit, we've gone back to series circuits. For question number 2, if the ammeter moved to the right of number 1, resistor number 1, would that change the reading of the ammeter? For this question, we need to think, does current stay the same in series, or does voltage stay the same in series and current changes? In this case, because we're in series, current in series stays the same. So if the ammeter were moved, would that change the reading of the ammeter? The answer is no. A proper way to, if you see this question on a quiz, make sure you always include why. So if the ammeter were moved to the right of resistor 1, would that change the reading of the ammeter? You would answer, no, that would not change the reading of the ammeter because current stays the same in series. And if you want, you can also include the example that in series, the runners don't have any choice. They're stuck in the same loop. So what will the ammeter read if it's to the right of resistor 1? So in this case, we're looking for voltage. So in this case, we're solving for current, and we need to know the voltage and the resistance, but which voltage and which resistance? In this case, since current stays the same, we can use either individual currents through individual resistors, or we could use total currents and total resistors. Which is better, solving for individual currents with individual resistors, or solving for the total current by using the total amount of resistance? In this case, it'll be easiest to solve for the total current using the total amount of resistance because we also have the total voltage. So since we're given the total voltage of 9 volts, we should also use the total resistance. So in this case, we have a resistance of 1 and 1 and 1. So our total resistance is 3. 9 divided by 3 is also 3, but because we solved for current, this is 3 amps. Question number 6. This is the last question we'll do for this video. What kind of circuit is this? Rank the voltage drops for each part of the circuit from greatest to least, and determine the resistance of resistor 3. Pause the video to make sure that you give yourself time to work. This circuit is a parallel circuit. The voltage drops for each part of the circuit, so it's asking if we measured the voltage here, and here, and here, and here, how would those voltages compare? In this case, because we're dealing with a parallel circuit, the voltage for each branch remains the same. So now, determine the resistance of resistor 3. In this case, we need to work backwards. We have the total voltage, and we also have the total current from the ammeter. So we can solve backwards to the total resistance and then solve backwards again to the individual resistance. So in order to solve for resistance, we need to divide the voltage divided by the current, take the voltage and divide by the current. And like I just said, since we have the total voltage and total current, we can solve for the total resistance. So now we know the total resistance in the circuit is 2 ohms. So let's try to solve for resistance number 3. This is a little tricky because it's in parallel, but we know that the equivalent resistance is 1 over all of the other resistors. So we have 1 over the total resistance, or the equivalent resistance, which is 2, equals 1 over 8 plus 1 over 8 plus 1 over some unknown number. Let's simplify this a bit. We can add 1 over 8 plus 1 over 8. That will be 2 over 8. We're not changing anything else in the problem, so we are keeping everything else the same. Now we can simplify 2 over 8 into 1 over 4. Solve like algebra. We can subtract 1/4 from both sides. So we have 1/2 divided by minus 1/4 equals 1 over R3. 1/2 minus 1/4 is still 1/4. So that means our third resistor is 4 ohms. If you had a little bit of trouble with the algebra, make sure that you get familiar with your calculator. You can absolutely do this without using fractions. You can do it completely in the calculator. That's all the questions for this video. If you have any questions remaining, please make sure you ask in class or please ask in tutorials. The sooner you ask questions, the better.